Alex, did you know it's snowing outside?
I do know it's snowing outside.
You know what that means?
It's Christmas time. Almost.
Almost.
Very, very nearly.
But that means it's time for us to get fat. It's hibernation time.
I'm down for a hibernation. Let me tell you. Nice long nap. You wake up, you're skinny. Oh.
It'd be nice. It'd be nice.
Yes, sir.
But yeah, it's snowing in our neck of the woods. This is our first snow of the year. It's pretty nice.
It is. It's kind of
It's
nice
actually
outside.
sticking to the ground.
Yeah, it
compared
is
to, like,
surprisingly because it was
normal.
fairly warm at the beginning of the week.
Yeah. But today's topic has nothing to do with snow.
No.
Or-
And welcome everybody to Life the Complete Story.
Yep. As always, I'm your host Tyler, joined by my co-host Alex.
Hello, everyone.
Today we got a big not a big episode, but a bit like a solid chunk of info to talk about.
Yes, sir. Yeah. Today we're going over the skates and the rays, but before we get into our lesson, we always like to start with a little news article about some nature in the news. And this one today kind of is a combination of a little bit of nature and a little bit of medicine. Don't worry, it's not super hardcore medicine, but
It's pretty cool. I read it like 10 minutes ago.
Yeah. Today's article comes, and now this is just a news article. It's not like a scientific paper like something a lot of ours usually are. So, but this is on nature.com. It is from the 20th of November, written by Helena Kudiabor, I think is how you say that. And what it goes through is some researchers have figured out how to basically make a vaccine for malaria by genetically modifying the malaria parasite and then pretty much injecting it the way it typically would be using the mosquitoes, and it has allowed people to still be bitten by the mosquitoes without contracting malaria. So that's a pretty cool thing, pretty big thing in a way to stop malaria,
The way
Go
that
ahead.
works is they modify the malaria parasite, which is a single-celled organism, actually,
Yeah.
not a
Plasmodium falciparum.
Right. They modify that so that it stops. What do they say? It stops growth shortly after injection. So
Okay.
our body still sees the plasmodium, does all its stuff to get rid of it, but the plasmodium doesn't actually do anything. The parasites were engineered to stop developing shortly after delivery into a human. Yeah. So they won't continue to grow and reproduce inside of us.
Okay. So it's kind of the goal here. They wound up making two modified parasites. The first one stopped developing 24 hours after infection. The second one stopped developing about 6 days after infection, because with the first one they saw that it only really helped protect a couple participants against malaria. But the second parasite is said that it developed to about the point where the body really starts to see it, because that's when it starts to replicate in the liver cells and getting into the red blood cells. And it said after they exposed participants to 50 mosquitoes, 10 received bites from the GA1 parasite, 10 with the GA2. And then 3 weeks later, they exposed them to malaria-carrying mosquitoes. And just before exposure, both sets had higher levels of antibodies than before. But one of 8 participants bitten by the G1 parasite didn't contract the malaria, compared to the 89% in group 2. And so other than the itching from the mosquito bite, it really didn't have any side effects. So they're looking to now replicate that in a larger trial, which is something, if they can get the biggest problem with modifying something like this is they tend to mutate. So it's making sure that the parasite doesn't mutate in a way that makes the modification really useless, and then getting it to outlast the regular parasite that so that way that becomes like the dominant one, and eventually the parasite pretty much dies off on its own.
Here's my question.
Yeah.
How did you convince 50 people to say, hey,
Money.
you want to get bit by a mosquito?
Money is usually what it is.
Yeah, that just seems kind of far-fetched. You walk into it. Let's say you
People
walk
do
into a
dumber
town.
things for money. People do dumber things not for money.
Yeah, I know. We're friends with each other. Yeah.
Yeah.
But, like, you willingly ask somebody, hey, do
You
you
want
want to try
malaria?
not to get malaria for money
I'll give you $100.
to get bit by this mosquito? It confuses me, but
It's kind
to
of
each
special.
their own.
Yeah, but regardless, that is a big. And it does say here at the bottom, there's 2 references. So those look like the articles that these trials have been made from. So if you want to read more on the actual article itself, it is at the bottom of this page if you
Yes, sir.
find this article. So, I mean, it's still a big thing because malaria affects about 250 million people a year, primarily in more tropical regions, which tend to be the poorer regions of the world. So it's something that is very, very important to try to help, because it can cause a lot of damage and even death in some people.
Well, if that concludes today's news article,
I believe it does.
we'll move into our lesson for the day. Today we're talking about Batomorphs, or the skates and rays.
Yes.
They're the largest group of cartilaginous fish, so we've covered sharks already, and they're decently sized in terms of population, not populations, but in terms of diversity. But there's over 600 species of skates and ray, divided into 26 families.
That's a lot.
These four orders or suborders.
They're orders.
They're orders. Okay.
Yes, they're
The
orders.
classes. Chondrichthyes.
I believe so.
Yeah. Okay.
Yes.
Yeah. I know my
Yeah.
diversity.
Yeah. Class Chondrichthyes, subclass Elasmobranchii, and then
Order.
order, or no, super order. No. What are Batomorphs?
You lost? Me too.
Yeah, I lost myself. It's just a clade. I think it's part of the super order Batoideae. That is what Batomorphi is.
Yeah.
Sorry. I just allowed myself. I just confused myself there for a second. I apologize, everybody. Had a moment.
I confuse
We're
myself.
good now. We're back.
Every day.
We're back.
But as we
Locked
said,
in.
they are 600 species and 26 families across the entire Batomorphi, Batoideae, whatever you want to call it. In case you didn't know, stingrays and skates are relatively flat.
Yes.
Dorso-ventrally. So like
a pancake.
Like a pancake. Because there's other things that are like this flat.
Yes.
I forget what that's called.
Ocean sunfish.
Well, yes. But
yeah.
no.
Yeah.
The actual terminology for being vertically flat instead of like pancaked.
Laterally flattened.
Laterally flattened. So that's like your ocean sunfish.
I guess. Yeah, or just
like that.
most fish in general. But we haven't got to them yet.
They have 5 ventral gill slits or on their bellies. Yes. So they don't use them
finding pictures
super frequently, since they're on the bottom, and most of these skates and rays live on the seafloor. So they use the spiracles that we've talked about in the past, which are located around their eyes, as their main breathing mechanism. They are, that's a great picture.
It's a great picture. Is a pelagic stingray.
That's what it's called.
Yes, that is what that is.
Awesome. They have a lack of an anal fin. So the anal fin is like not quite the caudal tail fins, but it's like in that same. It's like right before that part. They don't
Yeah.
have these, which I didn't think the sharks did either.
I don't think so, because in fish, that's the fin that comes down pretty much where the anus is. There's like a small fin. Yeah, I don't believe the sharks did either.
They have claspers instead.
Correct, which is like a modification of the cloaca, I believe.
Yeah, it helps with mounting for internal fertilization,
Correct.
which these organisms do. I apologize, people, if I keep looking this way. I'm staring at Alex.
Oh,
In case you haven't noticed.
multiple screens.
Multiple screens, big screens. It's hard to look at Alex. As I said, most species live on the seafloor. However, some, and most of them are like a coastal seafloor, so like up until you get to that continental shelf. So like in terms
Like
of like,
reef areas
yeah,
and like kelp forest sort of locations.
yeah. If you look at a map of the ocean and you take off the water, it kind of has this like shallow grade for like the first couple miles off the coast,
And
and
then
then
it
you just hit a
drops
wall.
off.
So that's where like most of the stingrays live in that area. However, some are deep sea organisms that live over 3,000 meters deep, which is insane.
That's pretty far down. I mean, that is a couple miles.
Yes.
Yeah.
And even still, some organisms live in open water. Obviously, the
Like,
pelagic stingray does.
yeah, like the one
Uh,
that we have showed up.
some eagle ray species do. Some most manta ray species do.
Eagle ray? That's the
Uh,
spotted eagle ray.
that's the teacher from Finding Nemo. Is an
Yes.
eagle ray.
Yes.
I think his name is just called Mr. Ray.
Yeah, I believe it is.
And even still, some species live in fresh water.
There's
Where you
not.
cool. There's not a lot of them.
Yeah.
But they exist. And they have these heavy round teeth that they use to crush the invertebrates that live on the seafloor as well. That's how they feed. It's pretty cool. So we'll move into our first order of stingrays. This
Okay.
is gonna be
Yeah.
the actual true stingrays.
Yes. So our first order of stingrays is Batomorphs, which is the true stingrays, as we said, comprised of 12 families. These are a lot of them are referred to as the whiptail stingray as part of this group. I think that is the family Dece today. They are found primarily in tropical and temperate waters worldwide. There are some that have made their way into freshwater locations in Africa, Asia, and Australia. They have a very long whip-like tail, thus the name whiptail stingrays. And a lot of them tend to have a venomous barb or like a stinger near the base of the tail. And this is something you'll see with a handful of the stingrays, kind of a defensive mechanism primarily, not a predatory mechanism. In the family, this is going to be a rough one. Batomorphs. I think
That was pretty good.
I think that was pretty good. That was one of my better ones. These are known as the river or freshwater stingrays, found in South America. They range anywhere from 1 to 6.5 feet across, so like 30 centimeters up to 2 meters across.
Yeah, they're pretty big actually.
Yeah, some can get quite. I mean, if you think South America, like the Amazon, it's a very large river. Areas like that, they've got some big lakes in that as well. They also possess the venomous tail stinger, and some of the species in this family are sought out as a food source and even exported to Asia. So if that's something when we get to our amazing species, that may be something we look at.
It's really funny because it's bycatch most of the time.
Yeah, they just don't want to throw it back.
So they eat it, and they're like, "Oh, it's pretty good."
I mean, it's got to be good enough that they don't throw it. Just throw it back.
Yeah.
And then the next family is the butterfly rays, the family Gymnura. They have broad discs and a very short, kind of thread-like tail. They are found warm, wide, and warm ocean waters, can grow up to 13 feet across, so they can get quite large. The deep water stingray is the sole member of the family Plesiobatidae. So they're found in the Indo-Pacific at
This is your
depths.
Gymnura, by the way.
Okay, so they're very wide with a very short tail.
Yeah,
Okay.
they're unique.
They are interesting.
Deep water
Plesiobatidae, yeah. Depths over 2,000 feet. It can be about 9 foot long, 5 foot across. So these ones are going to be a little more the opposite of the one we just saw, where they're going to be much longer than they are wide. And if you include the tail, that's the case with most stingrays. Next family, Europlopidae. These are known as the stingarees. Sting, Arees. They're relatively small, growing up to about 32 inches across, found across the Indo-Pacific in the shallow waters, and have the greatest diversity around the coast of Australia. I'm sure a lot of that has to do with the vast reef system that surrounds the Australian continent. Second to last, we have Aedobatus and Myliobatidae. These are the families of the eagle rays. They tend to be larger, broader, open ocean species. Some of them capable of breaching several meters above the water, so they can jump quite high. These are, when you think of stingrays, these are probably the ones you think of, like the picture we showed earlier of the pelagic stingray, the eagle ray, the spotted eagle ray. Those are your...
Or you think of the next group.
Or the next group, yeah, most likely. Which is Mobulidae. These are the manta rays. These are large open ocean stingrays. They, I think, rather than eating like crustaceans or invertebrates, I believe they do more of a filter feeding.
Mm-hmm.
So
They eat more plankton.
yeah, so if you guys remember from last week, 2 weeks ago, the whale shark, the basking shark, same idea. Now they start getting larger. They have a large mouth. You can see at the front there, below the... I don't even know what those are called.
Oh, I have no idea either.
I don't remember.
I
I have to look it up.
I'll let you
But
talk and I'll look at it.
yeah, but because they have the larger mouth and everything, they typically filter feed for plankton rather than actively hunting because it's more efficient. But they tend to be very friendly. There's a lot of documented cases of people being able to pretty much just swim right up to and kind of hang on to a manta ray as they swim through the ocean. A lot of divers. They can also breach. It's kind of crazy to watch them breach because they are quite large.
They're called cephalic fins.
Cephalic fins. Okay, so they're like little fins.
Mm-hmm.
Okay. Yeah. And how big can a manta ray get? They can get quite large. Probably what, like
18 feet.
18 feet wide?
Mm-hmm.
Yeah. So they get very big.
Oh, that's the smaller Mobula alfredi. That's the reef manta.
Oh, what about the pelagic manta or
The
whatever?
giant oceanic manta
Yeah, that one.
reaches sizes of 18. Wait, what the hell? I lied to you. 23 feet.
Okay. Yeah. So they can get quite big. That's bigger across than the room I'm in. Like
Yes.
by twice. So it's a pretty big ray. Well then, Tyler, I'll let you take on the next group then, because unfortunately today with the rays, the first group that I just did is kind of your most complete group. And then
there's
the
not
next
a lot
one's
more.
not too bad. The last two are kind of, unfortunately, there's not a ton about them.
Nah. So next is going to be the Ragiforms. These are your skates. So there's 4 groups within the Ragiforms. There's not much of a difference between a skate and a stingray in terms of like physiology and stuff. They just don't. They lack the stingers the stingrays have.
Okay.
And they have a more like fleshy tail. It's not
Okay.
as whip-like. It's also stubbier in most cases.
Actually has like some. A lot of times it'll actually have like a fin on it. Man, no, not necessarily. No,
So we'll start
some of
with
them
the
do.
Anacanthobatidae. These are your smooth skates or your leg skates. They're found in deeper water, about 200 meters, 600 feet-ish. And they're called smooth skates because they lack those dermal denticles. So we talked about briefly last week or the week before when we talked about sharks. The denticles are like the pseudo scales that these types of fish have. They don't have like an actual scale structure. They're more like a tooth-like formation on their skin.
There's a skate.
Perfect. Next, we'll go into Arhinchobatidae. These are the soft-nosed skates. There's about 104 species and 13 genera. They're different than hard-nosed skates because they have a soft nose instead of a hard nose. Hence why they're called a
Oh,
soft-nosed skate.
oh,
Um,
getting
it,
real technical here, aren't
that
we?
that softer nose is also more flexible, and the rostrum is more uh, reduced. Next, we'll move into. You're killing me, Smalls.
Good luck.
Uh, Gurgasilidae.
Honestly, I think that's the best he could have done. That was
They're the
pretty good.
they're the pygmy skates. They're small. That's there's 3 genera.
Wow, they're small. Way to get that good scientific information, Tyler.
What do you want me to say? I can't even tell you how big they are. Like it doesn't tell me. There's 19 species and 3 genera.
Yeah, there's
The
not a whole lot about them.
No, you don't even have a size on this one. This sucks. I wish I could help.
Yeah, I mean, there's
Here we
no.
go. The Atlantic pygmy skate has a width of 19.6 centimeters or 7.7 inches.
Yep, that's
That's
pretty
small.
small. Yeah, it ain't. That's pretty small.
And the last group is the bigger group. They're called Ragidae.
Wait, wait. Are these the hard nose skates?
These are the skates. But yes, they have hard noses. So I guess by proxy, they're hard-nosed skates. So they give birth to eggs. So they're oviparous. They lay eggs in those mermaid places we've been talking about
Okay.
heavily. Some skates have an electric organ, so that's their self-defense mechanism. And their electric organ exists in their tail. The electric eel, their electric organ exists along the.
I believe so.
We'll talk about it later when we talk about electric eels. So we're
Yeah.
not gonna get big into it now.
Yeah, we'll have to
And
get a little more in depth on that one.
as we'll talk about the electric ray later, the electric organ's in a different spot. We'll talk about that in a couple minutes, guys. But skates are found worldwide, and they're not as particular in terms of like neotropical stuff. They can live in more temperate waters. Even some live in the Arctics, like up towards the Arctic Circle as well. So that's gonna cover our skates. We'll move on into the next group. Alex, would you like to cover?
The rhinopristiforms.
Yes.
Yes, sir. Let me pull the notes up. So the rhinopristiforms. This is an order of rays that are known as the shovel nose rays. So I'll stop sharing if Tyler wants to pull a picture up. So these contain the families Trigonorinidae, which are your fiddler or banjo rays, Rhinobatidae, which are the guitar fishes, Rhinidae, which are the bowmouth guitar fishes or wedge fishes, Glaucostigidae, which are the giant guitar fishes, and then Pristidae, which are the saw fishes. So they are.
You might want to talk about them a little bit since we talked about saw. What did we talk about? Saw sharks last week.
Yeah.
Or 2 weeks ago, I was sick last week. I
Yeah,
didn't tell you guys that.
Sauna, sure. Yeah, it's been a couple weeks. We apologize. Well, Tyler apologizes because his whole family was sick, and he was sick for a few days, so
Yeah.
did not get to record. But he's better now. So the sawfish, also known as the carpenter sharks, even though they're not sharks, they're a family of rays. They have a long, flattened rostrum with like teeth that come out on either side of it, horizontally, looking like a saw blade. They are some of the largest fish, reaching lengths of 7 to 7.5 meters, or 23 to 25 feet. So while they are technically rays, or in the grouping of rays, they look more like sharks. Why they're called carpenter sharks. Found worldwide in the tropical, subtropical region, really marine and brackish water, but they have been found in freshwater rivers and lakes. And all the species currently under are critically endangered, all of the sawfish. So because of their rostrum, they were sought out from centuries. Is kind of in ancient times there been use of their rostrum for like weaponry in native cultures, as well as kind of mythological spiritual roles in societies. And they're relatively slow breeders, and they give birth to live young, in which they feed on fish and small invertebrates that they are able to detect and capture with the use of the saw. They really are generally harmless to humans. They really use just the saw just for their own like feeding, but they can, if they are caught and like if you try to catch one and it tries to swim and wiggle when trying to defend itself or get away, it can cause some injury. So just leave them alone. They're just cool guys trying to live their life. Let them go.
Words to live by.
Absolutely. And then there are two other families that are around, but they're associated in rhinopristiforms, but they're not 100% sure because they haven't quite figured out their phylogeny yet. And these are the family Platyrrhinidae, which is the thornback rays, and Xanobatidae, which are the pan rays. These two, currently they are placed under the order Rhinopristiforms, but that could possibly change. They're not 100% as far as they're where they belong yet. But with the Rhinopristiforms as a whole, typically exhibit slow growth at a later maturity, as well as kind of a low birth rate. So they are, because of these things, that it makes this whole group very susceptible to extinction. And like we already said, because it kind of did a highlight on the sawfish family, that is very obvious by every species in that family being critically endangered. They're very prone to being caught in fishing equipment, especially like trawl nets or seine nets, and then being caught with just a hook, regular fishing hook. A lot of times they're caught for their meat, but mostly their fins. And typically the meat is consumed locally, but the white fins are considered a delicacy in a lot of the world, highly sought after, which is thus leading to their rapid decline because their fins are in such high demand. So definitely something we got to keep an eye on, kind of protect these guys a little bit. They all look pretty cool. Not just the sawfish, the guitar fishes look pretty cool too, and the banjo rays. They're all cool looking dudes.
Yeah, they look funny.
I'm gonna share a picture of a shovel nose real quick, just so you guys get an idea of what that one looks like. See how it's got the very
got a shovel
large.
nose.
Yeah, it kind of, you can see why it's called a guitar fish. It's kind of got a general shape of like a guitar, with the tail being like the neck of the guitar and the body being the body of the guitar. So it's kind of, they're pretty cool. Like most other rays, they live primarily on the seafloor and near reefs, places where there's going to be a lot of food. Makes sense.
All right, so with that, we're going to move on into our last group for the day. We're going to be talking about the torpediniforms, the electric rays.
Ooh.
So, once again, flattened, round disc-shaped bodies. They have a more muscular tail compared to other stingrays who have that whip-like. And their electric organs are like kidney-shaped, and they're in the pectoral fin area, in that disc area. So rather than the skate having it in the tail, these are like in the actual body in those pectoral fin areas.
That's
And
pretty
it's kind of
cool.
been like a folklore thing, since we never really like understood. We just got shocked by these things. They were thought to
Okay.
be they were thought to be magical because they could shock us without touching us.
Interesting.
There are 1, 2, 3, 4, 5 families in this group. There are the thornbacks, I believe, to be either in this group or in the previous group. That's where
I think. Okay.
that's like what the phylogeny is like tossed up between.
That makes sense.
The sleeper rays are in the family Narcidae. They're about 46 centimeters tops. They have no thorns, no dermal denticles, no nothing. So they're smooth, naked skin, and they have those shocking organs. They're typically a brown or red, and they could have spots, splotches, or any type of band on them as like a camouflage pattern.
Okay.
Next, we have the Narcinidae, which is the actual electric ray family. They're small to medium,
Yeah.
no more
Here.
than
Little guy.
yeah, that guy. About 66 centimeters is like their typical range, but most are less than 50. They're slow swimmers, as most of them are. Their body shape doesn't provide very much in terms of swimming power.
Yeah.
They kind of like undulate their fins to move, right?
Okay. Rather than kind of swimming with their tail. I mean, I'm sure they use their tail
Yeah,
a little bit, but yeah, most rays tend to undulate their pectoral fins, which are the ones out to the side for movement.
we have Hippinidae, which are the coffin rays, and they look funny.
Yeah.
I wouldn't see this as a stingray if I was like snorkeling or something.
No.
This
I
is underwater moss.
Yeah. Oh, pretty much.
It's a lichen.
Yeah, it's very goofy looking.
Yeah, it is the I believe it's the only species in its family.
Okay.
Hypnosmonopterygius. Apparently it can eat penguins and rats.
What?
That's
And
what
it
I'm saying.
Yeah. It must be bigger than it looks.
It's about 16 inches, so I don't know where the penguin comes in. Although it lives off
Babies?
Australia, the baby blue penguin, the little blue penguin.
Oh yeah, they're very small.
Yeah,
I don't know. Strange.
yeah. But its main diet is bony
Invertebrates,
fish
probably.
and invertebrates. Yeah,
Yeah. Typical skate food or ray
yes.
food.
They're kind of funny looking though.
Yeah, they're weird.
It's very like ununiform for like a higher life form.
Yeah, still have that bilateral symmetry though. Can see it.
Yes. And then lastly, we have Torpedinidae. Yeah, they're same things apply, just a different genus. They're bigger. The largest species was 200 pounds
Jeez.
and had a 220-volt electric shock.
That's like so for at least in America, if you have like an electric stove or an electric dryer, that real thick wire, that's the voltage that comes out of that. So it's a lot. That would hurt.
Yeah.
That
And
would
they
hurt.
can like these electric rays can kind of like store their electricity in their tissues. It's like a battery.
Ah, that's pretty cool.
Yeah. Which is cool because it's like a venom gland almost, where it's like,
Yeah.
but it's an electric tissue. I feel like that doesn't make your meat very good.
I don't know. I mean, probably when they die, it discharges eventually.
Yeah, and I'd assume it discharges like into the tissue.
Not sure.
Uh, who knows?
Asking the wrong guy.
That's our well. That's kind of our job here.
Ah. Let me
uh,
rephrase. I have not done enough research into that specific topic.
well, with that, that'll conclude our lesson for the day. We'll go ahead and move into our other segments. Alex, why don't you start us off here with our most wanted? And I saw this was not a
Alrighty.
stingray today, was it?
No, stingrays really don't become invasive. Typically, if you haven't noticed by now, a lot of the time your larger animals do not become invasive.
Hey, tell that to snakeheads.
I said typically. Snakeheads are an exception. They kind of do their own thing. But especially in
They can
marine
walk on
environments,
land.
yeah, they're wild. But our invasive species for today is a invertebrate. It is a whelk, which is I know, drawing a blank. What it is the veined rapo whelk or Rapana venosa. It's a snail. Sorry, I've drawn a blank on what a whelk was. I apologize. It is native to Asia, if I remember correctly. However, it was found in uh, European waters like the Black Sea, and then in the Chesapeake Bay in the very late 90s, early 2000s. And because it is a large predatory snail, they grow about 6 to 7 inches in length with a very heavy shell that has like a short little spire on it. The shell gets almost as wide as it does long, so it looks fairly boxy. It has that gray, reddish brown, dark colors to it, um, with a kind of a black veination throughout. Then the inside is a very dark orange. But the problem is why they're invasive, and what, especially in an area like the Chesapeake Bay, which is a very important estuary, is because they feed on bivalves primarily, such as clams, oysters, mussels, things that are important for filtering the water, um, as well as they're an important food source. Um, and they eat them by smothering the prey, by wrapping themselves around it, around the hinge, and then kind of forcing the bivalve open and then feeding on them. Now, fortunately, they do have some predators, such as turtles and other large predators that migrate. A lot of times that can prey on the younger ones while they're still smaller. The shell's not quite as heavy, but once they reach adult size, they really don't have any predators because the shell protects them so much. So another reason why they're so invasive is because they're very tolerant to a lot of things that a lot of other aquatic organisms are not, such as large temperature fluctuations, pollution, low oxygen levels, things that make them pretty much designed to be an invasive species. And they can lay a bunch of eggs during the summer months, which hatch in about 20 days, so they reproduce and hatch fairly quickly. And then these young adults, or the young whelks, can grow very quickly in their first year and are able to reproduce by their second year of life. So they can reproduce at a fairly young age, but they live upwards of 10 years, so they live a fairly good while for a snail, I should say. But that is kind of all I have on the Rapple whelk. I mean, it looks cool, but not great for some of those coastal ecosystems.
No, not at all. Especially something as important as Chesapeake Bay
Yeah.
or the Black Sea or things of that nature.
Yes.
But with that,
Some major fisheries.
yeah. With that, we'll move on into our next two segments back to back. We got the amazing species for the day. Today's amazing species is a skate, the common blue skate, and it's not so common anymore.
And I'm guessing not, because otherwise
It's
we wouldn't be talking about it.
it's critically endangered. These are found off the coasts of like your northern European countries. So like off the coast of Norway, Iceland, the UK, Ireland, and like the surrounding areas. What are these islands off the coast of Ireland, Alex? Like between Ireland and Iceland.
I forget.
They also live in like the English Channel and the North Sea. They're cool looking. They got that very pronounced skate structure with the short rostrum and the nice little pectoral fins and the tail. Reading. Catch rates of common blue skate in England in the Western English Channel declined in the 20th century. By the 1920s, it was uncommon. So this has been like on the down low, like on the downhill for like ever. Oh, but
That's unfortunate.
this was critically endangered. It was assessed in 2021, published earlier this year in 2024. So
Okay.
in like the last 60 years, though, it has dropped 80% of its population, which is a lot.
Yeah, that is a significant amount.
It is used as a food source nationally, although not in like the local area.
Okay.
The European fishing vessels are banned from catching common skates. It is listed on several biodiversity lists on like their Endangered Species Act type, like what local like countries have on as their like national local species act, Endangered Species Act, similar to what we have.
Okay.
Scotland has a shark skates and rays. Order 2012, which prohibits the landing of a lot of things on rod and line.
So you can't specifically target these
Yeah,
organisms.
same thing in like Norway and Paris. They're in France.
Nice.
So there's at least things in place to stop this. This is a big overfishing thing.
Okay.
But this has been so bad to where it's been like catch ratios of this skate versus like the flapper skate were 150 to 1.
Goodness.
But that's gonna do it for my amazing species. There's not really much to it. It's going extinct, but we're trying to stop it by limiting fishing. Obviously, there's a couple bad eggs that still do that.
Yeah, I mean, it is unfortunate, but it is what it is.
So we'll move into our From the Vault, which is going to be a species of eagle ray known as Atobatus poae. It was an
Okay.
eagle ray, Cuba. When were we? Open image in new tab. Here's your artist rend. Can you stop sharing your screen, buddy?
Yeah.
Here is your artist rendition. Oh, so beautiful.
That's freaky looking.
But in case there's a diver for scale, and the Aobatus poie had a wingspan of 10 meters.
Okay.
So that's pretty big. That's why I decided to cover it today.
Yeah, I mean, that's a big guy.
Yeah, it's really cool. And that's really its claim to fame. It lived during the Miocene period,
Okay.
which is about 23 million to 5 million years ago. So post-dinosaurs.
Indeed. That is after the dinosaurs, sadly.
Yeah. Yeah, that concludes today. As always, I was your host, Tyler, joined by Alex. If you have not already, follow us on Spotify at Life the Complete Story. Subscribe to our YouTube page at Life the Complete Story. I'm still working on getting previous episodes uploaded there.
Okay.
It'll be fixed. Probably
Working
before
on
this
it.
episode comes out.
Getting there.
Follow us on Instagram at Life Complete Story. Lots of cool things happening there.
Yeah.
Amazing species, clips. Follow us on TikTok at Life Complete Story. Find us on Facebook at Life the Complete Story. Am I missing anything?
I'll
Send us an email. Email.
Dude, you get just running the whole list. Yeah. Pretty much everywhere. Life the Complete Story. Facebook, Instagram, TikTok. Send us an email, lifecompletestory@gmail.com with any sort of questions, comments that you have. If you want to learn something,
if you have
learn
an
more
idea
about
for
us.
a new segment,
Yeah, or new segment, something you want to learn about. a group that we kind of glossed over that you'd like to know more about, that'd be something we'd absolutely love to try and get into, research a little more if you all want to know more about it.
And we can do it so it's more of a video form than a podcast form. We'll go like on a deep dive. If you guys have something you really want to learn more about, we can do a deep dive on certain families or orders or something that we might have just done a quick over in one of our episodes. But as always, learn something new.
Keep on learning.
And we'll see you guys next week.
Next week. Yes, sir.
For holocephali.